Hey, welcome back. This is our third installment of Innovation Never Rests. Every other week, we've been releasing a new blog and video that showcases the latest and greatest features and enhancements available in Dundas BI, which just so happens to be the #1 business intelligence platform as rated by real users. Now, this week, what we're going to be focusing on is one of the new ways that Dundas BI simplifies data models and enables users to more easily explore data in a logical and organized fashion by using hierarchy attributes. So let's get right into it. In a nutshell, attributes are known to describe the values of a hierarchy, such as the color or size of a product, in, say, the product level of the hierarchy. So, for example, if you've compiled data that references retail transactions, you'd likely be measuring each transaction cost, or in other words, the sales amount. Now, sales amounts alone, however, do not amount to much insight. We'd likely need more information, such as the times the transactions took place at, or what we could call the date dimension, the parties involved in the transactions, or the customer dimension, the stores the transactions occurred in, which would be the store dimension, the items the transactions were comprised of, which we could also call the product dimension, and so on and so forth. You get the picture. But there's more to it than just that. In addition to the dimensions that we need to explain the transaction cost, we'll also need information that describes each dimension. Now, this is where attributes come into play. So if, for example, we take a look at our customer dimension, some of the attributes that we may be interested in would include customer name, customer address, customer zip code, customer date of birth, so on and so forth. Well, up until now, we've really treated attributes in Dundas BI simply as regular dimensions. Now, if we were to use the example that we just went over, that'd mean that customer name, customer number, customer address, we'd consider all of these to be dimensions as opposed to attributes. However, what often tends to be the case, and what we've noticed a lot, is that the majority of these attribute-type dimensions are actually used as mechanisms for describing different dimensions. Well, with Dundas BI, it's now much easier to model these. So for example, let's imagine that we have a product hierarchy that spans across different product levels. So we'd have the product category, the product subcategory, and then to describe each product, we'd have product color. What many Dundas BI users are accustomed to is treating product color as a separate dimension in their data. However, with the release of hierarchy attributes, that so-called dimension can now be recognized as an attribute that describes the product. Now, what I'm sure you're all wondering is, what exactly does this mean for you? Well, first, no longer are you required to endure the process of unnecessarily modeling dimensions, and subsequently laboring through joining them to the table that brings up the additional dimension and including it in our data model. Now we're able to build standard hierarchies, isolate different levels, again, product category, product subcategory, and apply attributes to them with ease. Not only that, but with this new addition to Dundas BI, end users will enjoy having their data organized in a logical fashion, making their exploration process so much easier, as attributes are now shown under the relevant dimension that they choose to describe, rather than as a separate dimension. Adding to the allure of hierarchy attributes is the fact that they'll greatly simplify the tables that users create as they drag and drop additional data into their analysis. Dundas BI will not attempt to aggregate data for attributes, meaning that users will no longer see totals and subtotals created for attributes in addition to those created for the respective dimension. What else is really important to note is how attributes impact the concept of in-memory usage, and whether or not users decide to store their data models in this fashion to boost performance. As it stands, in-memory storage is usually able to boost performance as it pre-calculates most of the possible aggregation and then stores these in advance, so that when users are exploring the data, the results are often very quickly returned to them. However, since there are even less aggregations required with attributes, your in-memory models will require less memory, specifically RAM, making the process of both building and storing an in-memory model that much more efficient. And that's not all. In addition to all of these benefits I've already mentioned, the other thing we value in regard to attributes are time attributes. Now, many of you likely possess very cyclical data or operate a cyclical business. And need to compare same months across different years. So for example, January 2018 versus January 2019. Well, with hierarchy attributes, that analysis immediately becomes so much simpler. Now, rather than having to return to your data model to create separate dimensions for every attribute related to time, such as the month of year, we're now able to apply built-in time attributes, thereby expediting this analysis. But again, talk is cheap, and a picture, or in this case, a video, is worth 1,000 words. So let's see this concept in action in Dundas BI and dive a little bit deeper into how attributes can be used to your advantage. Alright, so here we are in Dundas BI, and the first thing that I'm going to do is build a new hierarchy. So let me just go ahead and do that. And I'm going to expand my AdventureWorks database. I'm going to grab the product table, and I'm going to drag that onto our database. And now, because I already have relationships defined within my database to different tables, such as a subcategory, category of the product, you can see here that it's automatically identified this hierarchy for me. And now I can see at the different levels, I can actually choose the right level and add an attribute to it. So this is one of the additions that we've made to the standard hierarchy. I can come in here and I can say, you know what, for the product, I have different fields that would describe the product, different attributes. So again, if we go into the attributes, you can see all these different attributes that we can add, such as product color, product class, product ID, so on and so forth. So in this case, let's go ahead and add the product class and the product color. So now once I've defined this hierarchy, I'm going to go ahead and give it a name. So let's go down here, and how about we call this product with attributes. I can now go ahead and create a new data cube, a new data model. And I can bring in my fact table here, some kind of table that describes the actual factual data that I have and that I want to use this hierarchy with. So in this case, I'm going to grab my sales orders. And now in here, what I can do is I can promote and use this new hierarchy that I've just created. So you can see it here, product with attributes. And now I can use that, and you'll see here that it has those two attributes that I just defined clearly provided to me as separate folders in that hierarchy. So what I'm going to do now is use this one. And what this is going to do actually is make the user's life so much easier when he actually explores the information. So for example now, if I were to add this to a new metric set, what I can do here is expand the product ID, and you'll see now that I have these two attributes available to me. So let me just go ahead and add these two products. And let's say that I want to see the information for the product color as well. So let me just go ahead and add that to the addition. And now what we can do is revisualize this as a table. Now you'll see that the product color is not applicable at the first two levels because I only added the attribute at the product level and not at the category or subcategory level. But when I expand to that product level, now we start seeing the value for the product color. And of course, we can also add the class as well. So let's go ahead and do that. So now I've added the product class, and you can see that it's been added as well to the table describing my data, but it's not adding a new hierarchy that I need to create aggregations by. So there's a couple of benefits here. First of all, the information is organized very nicely for the user. They don't need to look for their data, and they know those attributes related to that specific dimension, so that makes their exploration much easier when trying to do new analysis. And in addition to this, when I'm using these types of attributes, I'm actually reducing the number of computations I need to do for the different types of aggregation, and that's very important whenever I'm doing data storage of my cube in memory. Because when I store my data model in memory, I'm basically pre-calculating all the aggregations for all the different combinations. Now in this case, I won't need to pre-calculate those calculations because I already have them from the product level because those attributes describe that product uniquely. And in that case, I'm basically saving a lot of storage room, basically reducing the amount of RAM, the amount of memory that I need on my server whenever I create those types of data models using my attributes. So if you already have data models today that could benefit from this, I would strongly advise you to do a comparison. Try the other data cube with hierarchies that are using those attributes, and then try to build that into memory and see how much memory space you actually consume with that model versus the current model. That really should be a big savings right there. Now, the other thing that we value with attributes is time attributes. So let me just show you a very quick example with that. First, I'm going to create a new metric set. And I'm going to use here an existing data structure. So we'll take here sales orders. And what I'm going to do now is I'm going to bring in my time dimension. And I'm going to look at the information not only at the year level, but also with attributes. And in this case, we've got them describing to me the month of year or the date of the year. So I'm going to add these and revisualize it to a table. And what you can see here is the year level and the breakdown of the different months. But the difference here is that instead of doing a drill down and seeing the month and the year, now I just get the month on its own, the month of the year. So the value in that is now the ability to actually do a switch here. So let me go ahead and change the order. Let me move the month up. And now what I'm doing is actually organizing my information by the month across the different years. So if I have cyclical data or a cyclical business and I want to be able to compare the months across the different years, that analysis now becomes so much easier with this new attribute. I don't need to go back to my data model now and create a different dimension with the month of year. I just have that already built into my time dimension, and I can do this type of time analysis now very quickly with these built-in time attributes. So that about wraps up this video. Hopefully you enjoyed it. Hierarchy attributes are a really great addition to Dundas BI that can help tackle your complex data models and really make the exploration process so much easier and so much more efficient storage-wise. The next video that we've got coming out in Innovation Never Rests is going to be auto prep for messy Excel files, so do stay tuned for that. That's going to be a really great one as well. If you are looking for some more information or you're looking to try out the product yourself, do visit our website where you're able to request a live demo of our platform, or you can download a free trial of the software and go for it yourself. And if you have any questions about this video or really anything in Dundas BI in general, please do send us a message at info@dundas.com. Thank you guys so much for watching.